Welcome to my YouTube channel and the website Global Math Institute. Here is grade 6 student in India. My passion of mathematics engages minds and helps to connect continents. We will explore quadrilaterals in this particular video. We'll learn the characteristics of squares, rectangles, rhombus, parallelograms, trapezoids, and kite. In case you want to learn and develop critical thinking skills, join my classes. Let's enjoy the lesson with Shravan. Hi Shravan, how are you doing?
Hi, sir. I'm doing very good, sir.
Okay, so today what do you want to learn?
I want to show you a worksheet about squares and its quadrilaterals.
Okay. So it is on quadrilaterals. Can you tell me what are quadrilaterals?
Quadrilaterals is a four-sided polygons.
Four-sided polygons. Very good. What are polygons?
Polygons are closed figures made up of full line segments.
Closed figures made of line segments. Very good. How many minimum line segments are there for closed figure?
3.
Can you give me an example of open figure if it is closed figure? That is correct. So it is not closed as this portion is open. Correct. Now, quadrilaterals are four-sided figure, and here we see there are 6 types of quadrilaterals in which you are interested. Correct? Trapezoid,
Yes, sir.
parallelograms, squares, rectangles, rhombus, and kite. Okay, so let's look into these properties one by one. So, can you move your screen? We'll begin with squares. Let me clear this screen now. Okay, let's look into squares first. So, can you tell me the properties of squares?
All sides are equal.
Yes,
They are all perpendicular.
correct.
They bisect at perpendicularly.
So they
And all
bisect
sides are parallel.
diagonals. They bisect diagonals. They bisect. So if I draw diagonals as I'm drawing now, then they are at right bisectors. So diagonals are, when say diagonals of a square are perpendicular bisectors, and they also, that means these two sides are equal, right? And these are also
Yeah.
equal. And they are also at right angles. So that is how you could show right angles, right? And squares, as you correctly said, all the 4 sides corners are at right angles. So all sides are equal. We show them with, you've seen the lines when I draw 2 small segments like this. These 2 segments are, all 4 segments are equal. That is how we can show. Parallel to each other. So parallel we show with arrows. Let me show you how in a figure. So this means this side is parallel. And then 2 arrows I'm drawing on the vertical lines. Those 2 are parallel. You get the idea?
Yeah.
So a geometrical figure could be represented like this. We could label this as ABC. So that we could refer to this as a name, which is a square ABCD with all the sides of the square are equal in measure. The sides are parallel to each other, opposite sides. Is that okay?
Okay.
And then all interior angles of the square are at 90 degrees. The diagonals of the square perpendicular bisect each other, right? So bisect, as I've shown it with 1 dashes, they are actually all equal, right? So that is a square. Now, second, properties of rectangle. Can you tell me what is a rectangle for you? How will you describe a rectangle?
Two sides are equal.
Opposite sides are equal, right? So how will I show it? I will show it like this. This side is equal and the other side is equal. Is it okay?
Yeah.
The opposite sides of a rectangle are equal. Next property is opposite sides are
The
parallel.
diagonals are perpendicular.
Opposite sides are parallel. Again, with an arrow, I am showing how they are parallel. Is it okay?
Yeah, okay.
So opposite sides are parallel. Now, all the interior angles are at right angle as shown here, correct?
Yeah.
The diagonals of a rectangle bisect each other, right? So let me draw the diagonals and they will bisect each other. It means what? So when I do this diagonals, in that case, this side, let me draw 3 lines here, is equal to the other side, correct? And let's say 1, 2, 3, 4, 1, 2, 3. So these are equal sides, okay? Now tell me one thing. How about this angle? Is this angle 90 degrees?
Yes, sir.
No, it is not. So this angle is not necessarily 90 degrees. Correct? It is only 90 if you have a square. You get the idea?
Yes, sir.
In square, it is 90. So that is also a difference between the two. Now tell me, is square a rectangle?
Yes, sir.
Yes, that is correct. So square is a special rectangle in which all the sides are equal, diagonals bisect at right angles. Is that clear to you? So
Yes,
as we
sir.
move along, we should relate one figure with the other figure. Let's move on. And now let's take rhombus properties. Yeah, move on. Correct. Tell me about rhombus. First thing, how will you draw a rhombus? Can you draw a rhombus?
Sure.
Draw. Doesn't matter.
One
Doesn't.
second.
Yeah, yeah, that's okay. Good job.
Oops, not so good.
Doesn't matter. So you can erase it. I'll just do a rough sketch on the side. So why you say it is not good? Because the opposite sides are not parallel. You wanted to make them. Is it okay?
Yeah.
So all 4 sides of a rhombus are of the same measure. It is kind of a square, but not at right angles. You see that? So let me just draw a rough sketch here. So see how am I drawing, right? So we have these sides, right? Okay. So we are saying that all 4 sides are equal. That means this length is equal to the other lengths as in the square, correct? The opposite sides are also parallel. So this side is parallel to the opposite side and these 2 sides are also parallel. Do you see that opposite sides are parallel? Correct? So we
Yeah.
have
Yes, sir.
all the 4 sides of a rhombus are of the same measure. So that is shown by 1 dash in red. The opposite sides of the rhombus are parallel to each other as we have shown with the arrows. The opposite angles are of the same measure. So also the angles, they are not right angles, but they are equal. Do you understand? So these 2 angles, they are equal and these 2 angles are also equal. So these are the opposite angles which are equal. Is that clear to you?
Yes, sir.
Perfect. Okay. So the opposite are same angles. The sum of any 2 adjacent angles of a rhombus is 180. Very important property. Do you understand this property? What does it mean? So let me write down, label this as ABC. It becomes easier. So first we learn opposite angles are of the same measure. That means we could write measurement of angle A is equal to measurement of angle C, right? These are the opposite
Yeah.
sides. And also measurement of angle B is equal to measurement of angle D, correct? Now we are
Yeah.
saying sum of any 2 adjacent side means measurement of angle A plus measurement of angle B is equal to 180 degrees. Do you see that? Similarly, the measurements of angle A And the measurement of angle D is also 180 degrees. Can you tell me why? So we want to connect this with our learnings. How can you connect this? Why?
Yes, sir.
Tell me why. Why are they 180?
Because they are like a line segment and a straight line is 180 degrees.
No. Because we have parallel lines. Do you see these parallel lines? So you remember when we
Yeah.
have parallel lines and we have a transverse line. Let me draw a transverse line here, right? In that case, the sum of, we call them co-interior angles. These two angles on the same side, their sum is 180 degrees.
180.
So this is these two angles, their sum is, when you add them, it is 180 degrees. Is it okay? You see, they form a
Yeah.
F kind of a design. You see, it forms a F.
Yeah. Yes, sir.
Yeah. So those are called co-interior angles. These are called co-interior angles. So make a note. Sum
Sure,
is
sir.
180 degrees. So we learned, we have connected this from parallel and transverse lines. Did you do parallel transverse lines earlier?
Parallel transverse lines, no.
Oh, you're not done? Okay. So whenever you have two parallel lines with a line which is cutting through them, so this line is called the transverse line. And those two lines are parallel lines. Is that clear? Which I
Yeah.
have shown with an arrow. So similarly, the sum of these two angles is also equal. Is it okay? So now you understand? It's good to remember. So when you have a figure in front of you, you can remember. So capture the figure. I should say capture the image. Now image is very powerful. It gives you so many things in one shot. You get the idea? Look at it very carefully so that you can remember what a rhombus is. Is it okay?
Yeah.
Now you tell me, is rectangle a rhombus? Is
No.
rectangle? No. Is square a rhombus?
Yes.
No, because square, yes, you're right.
Sorry, Rhombus. What?
Yeah, you're right. Yeah. Square is a rhombus.
Yeah, that's what I'm saying.
Correct. So the question was, sorry. So is square a rhombus? The answer is yes. So again, we see square is a special rhombus where all the angles are 90 degrees. Is it okay? They are, of course, parallel. Adjacent sides sum is always 180. And here, there is one more important, which is the fourth property, fifth property in this case. Can you read the fifth property? Very important property.
The diagonals perpendicularly bisect each other.
Same as in square. You see that?
Yeah.
So again, they are at right angles and they bisect each other, right? You get the idea.
Yes, sir.
So that is how a rhombus is. So their lengths may not be equal. In square, they bisect and all the smaller lengths of the bisected diagonals are equal. Here, we have one set which is longer than the other. Is that okay?
Yes, sir.
Okay.
Okay,
So
sir.
do you understand rhombus clearly? And all which we are talking about are quadrilaterals, correct?
Yeah.
Okay, let's clear this. Move on to the next quadrilateral.
So
Parallelogram.
can you just give me
Oh, sure.
just 1 minute?
Okay. So whenever you're ready, tell me.
Yes, sir. I'm ready, sir.
Okay. So parallelogram. Let me sketch a parallelogram. It looks more like a rhombus. However, the sides are not all equal, right?
Yeah.
Can you give me the access to write? I'm not able to write.
Oh, sorry. I didn't know that. I didn't
Okay.
see that.
Okay, no problem. Okay. Now, let me sketch a parallelogram. How will I show that opposite sides are parallel? Like this, arrows, right? So that is opposite sides are parallel, quadrilateral. So that is a major property. The opposite sides of a parallelogram are of the same length. So they are also same length and they are parallel. So we'll now put another sign for same length, right? Which is like this. Do you see how we put?
Yes, sir.
Correct. And opposite sides are parallel to each other. First two properties we have covered. The diagonals of a parallelogram bisect each other. Again, diagonals bisect. So they may be of different lengths. One is longer than the other, but they bisect each other. Is that clear to you? So we
Yes,
have
sir.
this equal to that. Let me write 3 diagonals. And this equal to this. Is that okay?
Yes,
So
sir.
they bisect. Opposite angles are equal in measure, same as in the case of rhombus, right? So we can say that this angle is equal to that angle, correct? And also we have the other angles. So opposite angles are equal. Is it okay? The
Yes, sir.
sum of two adjacent angles of a parallelogram is 180, just as because it's a parallelogram, right? So sum is similar. So this is a co-interior angles, correct?
Yes, sir.
So same property. So do you see how parallelogram is very similar to rhombus? What is the difference between the two? What is the difference between
Uh,
rhombus and parallelogram?
all adjacent sides are, all adjacent angles are of parallelogram are actually co-interior angles 180, the same. But yeah, that's correct. And the opposite angles are of equal measure. That's also
Yes.
same. I don't find some many difference here.
No difference between parallelogram and rhombus. Tell me.
Yeah, the opposite side of parallelograms are of same length, and rhombus all sides are same length.
So what is the difference?
Parallel.
All equal sides in rhombus. Do you see that?
Yeah.
Rhombus has all equal sides. Is that okay? Here,
Yeah.
only opposite sides,
I
right?
said that. I already said that.
What is the second difference between rhombus and parallelogram?
Yeah, same of that's one.
The diagonals, when they bisect, the length, they bisect and they are at right angles, right? So in rhombus, diagonals bisect at right angles. Is that clear?
Yes, sir.
But in the parallelogram, it is not right angles, right?
Yes, sir.
Not necessarily. So tell me, is a rhombus a parallelogram?
Yes, sir.
All rhombuses are parallelogram. Is a parallelogram considered to be a rhombus? No, other way it is not correct.
Yes,
Correct?
sir. No,
Yeah,
sir.
that is how you have to see and recall. Perfect? Okay, very good. Now, let's clear this. Move on. Properties of trapezium. Can you tell me what is a trapezoid and how do we define the properties of trapezium? Yes. Read the property. What is one property? Read them.
Only one pair of opposite sides of trapezium is parallel to each other.
Only one side, right? So only one side, not the other. So it could be the other way also. We could also make like this. You understand? So that is also one side is parallel. You see that? Okay,
Yeah.
next property. The two adjacent sides of trapezium are supplementary, means they are add to 180, right? So if I have this angle and this angle, then they add to 180, right? Let me call this ABCD. Then angle measurement of A plus measurement of angle B is 180 degrees, correct? Because we have parallel sides in this. Similarly, the measurement of these set of angles is also 180 degrees. Is it okay?
Okay, sir.
Correct. So this set of numbers is also 180 degrees. Okay, now next property. And even these is 180, right? So measurement of angle A plus measurement of angle D is also, all sets are 180. Is it okay?
Yes, sir. Okay, sir.
So what they're trying to say here is, if I give you one angle, let me write down a value here. Let us say this angle here is 70 degrees. Then what is angle B? Angle B will be how much?
Yeah. Uh, 70.
110, because you have to take away from 180 degrees 70, right? Because the sum is 180 degrees. Do you understand this?
Yes, sir.
So that is what they're trying to say. Is that clear to you?
Yes, sir.
Diagonals of trapezium bisect each other in same ratio. Same ratio means what? Let's try to understand this problem. So let me draw the diagonals, okay?
Okay.
And let me write down the point here, B, let's say M. Now in that case, same ratio means BM, that length over MD is equal to CM over MA. You get the idea? So that is the same ratio. Is that okay?
Okay, sir.
That's what it means. So
Okay.
these are the properties that the diagonals of trapezium bisect each other in the same ratio. Kite is like this. Looks like a kite. So in a kite, these two sides on the top are equal and the bottom are also equal. Do you see that?
Yes, sir.
And these diagonals, if I draw, the diagonals will intersect at a right angle. So one of them is called, one is smaller, one is bigger diagonal. Is it okay?
Yeah.
So this is smaller. So we got minor diagonal, or smaller minor diagonal, and this is major, bigger. So in a minor diagonal, the sides are also equal of the diagonal when they are bisected by the other diagonal. Is that clear to you?
Yes, sir.
Now let's read the properties. Can you read the first property?
The pair of adjacent sides of kite are of same length.
So as shown here, right? These are parallel pair of adjacent sides. Correct? Next.
The largest diagonal of a kite bisects the smallest diagonal of the kite.
So this is the largest which bisects the smallest. Is it okay? Minor, they are saying smallest. Is it okay?
No, which is the largest and which is the smallest?
In
I
this
suppose
case, this is longer, right? This is longer. And this is shorter, right? This is shorter, correct?
yeah.
So that gets bisected. Shorter gets bisected.
How?
Means this is equal. Do you see these two sides are equal when they bisect? Bisect means same length. So the longer one has bisected the shorter one. So these lengths are equal. Do you see that? Let me write ABCD just to clear, and M in between. So we know AM equals to MC. So that is bisect. Do you understand? Same length of the shorter diagonal. Do you get the idea?
Yes, sir. One
Oh.
second.
Okay, let's move on and look into the properties which are mentioned here for quadrilaters. Can you read through them and see if you understand all of them? Yeah, let me clear the screen. Yes. So the diagram
Rectangle.
is shown just as I was trying to draw. Equal sides are shown with, like you see, small things, right? Equal marks, 90-degree angles, and parallel lines. See how do they mention these things in their figure? Perfect. As I was trying to draw, that is how you have to draw each quadrilateral, correct?
Yeah.
Okay,
Okay.
let's move on and see what else is there. So that's an important summary page for all the quadrilaterals. Okay, next page. Is that all? There are two of you, right?
Yeah, it looks like.
Okay, great. Now I'll ask you questions based on our learnings, and I'll also explain you about trapezoid, right?
Sure, it's not fair.
You stop sharing. I will do it on a whiteboard. So you have understood this, but there are two things left. We need to understand what is a trapezoid and how it same ratio of the sides, correct?
Yeah.
So let me share with you whiteboard and from the okay, great. So let me share with you what is a trapezoid. We have one set parallel sides, correct?
Yeah.
So parallel sides we indicate with arrows. So this is a parallel side. You can make one or you can make two, something like this. Is good enough. Is it okay? Now we were stuck at the important point about the diagonals. So let me just make diagonals here. Joining the two vertices which are opposite. And let's label. They are intersecting at a point. Let's call this point as P. So what, see, these two sides are parallel, right? So we have actually two similar triangles. You understand similar triangles now? This
Yes,
angle
sir.
is equal. Then these angles are equal. So all the three angles are equal. So when all the three angles are equal, we can say that the triangle APD is similar. This is the symbol for similar. So triangle A is APD is similar to CPB.
Yes, sir.
Do you see? I did not write BCP because these two angles are on the side. Do you see? I'm taking care of the corresponding angles. Do you see that?
Yes, sir.
So similar triangles, right? This is the sum. Now, when that happens, in that case, the ratio BP over the side opposite to this is this. And for this opposite side, look at the corresponding side. What is the side opposite to this angle? That side, right? Which is BP, correct? And
Yeah.
opposite to this side is DP, right? So we can write BP over DP is equal to sides opposite to the vertical opposite, BC over AD is equal to the third side, which is CP over AP. So this is a constant ratio. You understand? These ratios are constant. That is what we say that diagonals cut sides in constant or fixed ratio. So we can say this is some constant k. Correct? So we could actually solve many questions based on this. For example, if I give you a side, let us say this side is 4 units BC, right? And A to D is 12. Then if you know that this side is, let us say 2.5, can you tell me how much will be A to P?
Yeah, would be the same as DP.
No, 2.5 times 3. Because see, this ratio is 4 and 12. So that means the bigger triangle sides are scale factor of 3, right? You understand? 4 times
Yeah.
3 is 12. Similarly, 2.53 will be the length of A to P. You get the idea now?
Yes, sir.
That is what it means. Is that clear to you?
Yeah.
So if this side is, let us say, we make this side as 3, then how much will be the other side here? P to D? 9. So you can now see that the ratio BP 3 over 9 is equal to 4 over 12 and is equal to 2.5 over 3 times 2.5, right? And what is the ratio? 1:3. Do you see that ratio? It is constant for all. That
Yeah,
is what
but
it means.
I don't understand. But I don't understand how you got that 4, 12, and those numbers.
Because each is constant. So this 4 times 3 is 12, right? How do you get 12? 4 times 3. So each
Where did you get 3?
12 divided by 4.
Then
Scale
where
factor
did you get 4?
is given, right? 4 I wrote 12 and 4 already.
Okay.
So this is called scale factor for similar triangles. So it is a property of similar triangles because all the 3 angles are same. Do you get the idea now?
Yes, sir.
Very good. So that is about similar triangles. Now, one of the most important property which you learned today, I will say, is the property of diagonals. So now, if I make a Venn diagram, right? And if I mention that we have one set where we have bisect diagonals at right angle. This is set A. And the other set is we have one set of parallel lines, or let us say 2 sets of parallel lines. Or let's write one set. One set of parallel lines. Then, how will you put all the quadrilaterals which you have learned today? Tell me. Where will each quadrilateral go?
Mm, very tricky one.
What comes in the center? You should begin with this. What comes in the center? Center means diagonals bisect at right angles, and we have at least one set of parallel sides. So what comes here? Tell me.
Rhombus.
Rhombus. Good. Correct. What else?
Square.
Correct. So these two figures will
Rectangle.
come here. No, not rectangle.
Why?
Rectangle
Okay.
diagonals do not bisect at right angles. Do you see that? That is the difference. Correct?
Oh,
Now,
yeah.
now we have one set of parallel lines. So tell me, which figures have one set of parallel lines?
the same rhombus square and
But they are already common, so we need not put them here. They are common.
rectangle.
So rectangle has one set of parallel side, yeah. And bisect diagonals right angles? No, it does not bisect right angles. What else?
And trapezoid.
Correct. And what else? Where will kite go?
Ah, kite. Yeah, forgot that.
Where? Kite does not have any parallel side, so kite will go outside. You understand now? Kite will be outside because in kite only this is it. We do not have parallel sides in kite, do we? We don't. And in kite, we do not have this bisect diagonals at right angles. So, so this comes here, not outside. Sorry, because they do not bisect. They are at right angles, but they do not bisect. Is that clear? So this will not come here also. So remember, in kite will come outside. Reason being, diagonals do not bisect in kite. Is that okay? They are at right angles. They are at right angles, but they do not
Correct.
bisect. So they will remain outside. You see how we have sorted out our learnings today, correct? So like this, you could actually remember the properties or practice with it when you do such things, correct? So Venn diagram, this is called Venn diagram, correct?
Yeah.
Okay. So we'll end the class here. I'd like you to summarize today's learnings.
So there are some 2 minutes, sir.
In 2 minutes, you summarize today's learnings. Yes. Summarize. What did you learn today?
One sec. I learned about diagonals. Polykite does not polykite is not part in the Venn diagram.
No. About diagonals, tell me from each property. What did you learn about diagonals of a square? Yes, tell me.
So square. Square, it has got 4 sides. All
No.
sides are parallel.
Only tell me about diagonals of the square. Okay. Yeah. Property of diagonals in square. Tell me.
Oh yeah, that's also not counted. Interior angles are 180. Then
No.
when we go to
Focus on the
then
question. The question here is, what are the properties of diagonals of the square? Okay. So do not tell me everything else. Just tell me the property of diagonals of the square. Okay.
the diagonals of square are perpendicular and
Yes.
are also perpendicular. They are also bisect at 90 degrees.
They are perpendicular bisected, you could say. Perfect. Right. And now what is the property of diagonals of a rectangle?
Adjacent sides are
Diagonals of the rectangle. Nothing else. Let's be focused. Give me properties of diagonals of a rectangle. Is it okay?
they're not bisect at 90 degrees.
They bisect. You say diagonals of rectangle only bisect, not 90 degrees. Is it okay? Tell me diagonals of a parallelogram.
Diagonals of a parallelogram. Four sides.
Do they bisect? Do they bisect? Yes, they do bisect.
Yeah, they do.
But they do not again bisect at 90 degrees. Tell me last, diagonals of a kite. Diagonals of a kite.
Diagonals of a kite. Yeah, diagonals of a kite bisect perpendicularly. I mean, but diagonals of a kite do not bisect. They do not bisect, but they are perpendicular.
One. They are perpendicular. Do they bisect any one diagonal? The longer diagonal bisects the shorter diagonal. Do you see that? So that is the
Yes, sir.
property of kite. So at this stage, we'll end the class. Thanks for your learning. Okay, then, all the best.